We're still in section 1.6 looking at solving equations with radicals. In order to solve an equation with radicals, we are going to use what's called the power property, which says if P and Q are algebraic expressions, then every solution of the equation P equal Q is also a solution of the equation P to the n equals Q to the n for any positive integer n. Now I'll show you this property as we're working problems, but basically it says if you've got expression equal to expression, you can take both sides of this equality and raise them to the same power. Now to solve an equation involving radicals, first thing you have to do is isolate the radical on one side of the equation. Isolate, get it by itself. Then you're going to raise each side of the equation to a power that is the same as the index of the radical, so that you get rid of the radical. If your equation still has a radical, then you repeat steps 1 and 2. If not, then you solve the resulting equation, and step 4, you have to check your solution, and this is extremely important. So let me show you how these steps work with this example. All right, this is our radical equation because here you see the square root symbol. So step 1 says that we need to isolate the radical. So that means we need to get this radical on the other side of the equal sign. So we're going to add it to the other side, and we get x is equal to the square root of 15 minus 2x. Now, step 2, raise each side of the equation to a power that is the same as the index of the radical. This is a square root. There is understood to be a 2 right there. That is the index. That means in order to get rid of this radical, we square both sides of the equation. So we'll take this x and we'll square this one. And we'll take the square root of 15 minus 2x, and we're going to square it. We square both sides of this problem. So x to the second power is x squared. When we square the square root, we get rid of the radical, and we have 15 minus 2x. This is quadratic, which means we need to put it in standard form to solve the problem because we have no more radicals. So we skip to step 3. So we have x squared plus 2x minus 15 equals 0. Now you can either factor this or put it in your quadratic formula. I'll put this in my quadratic formula. A is 1, B is 2, and C is negative 15. And I got that x is equal to negative 5 and x is equal to 3. All right, these are possible solutions. Now what happens when we square an equation in order to solve it? We actually changed the problem. Remember, this is the problem the way it started. This is the actual problem that we solved. So these solutions may not work in this equation. So step 4, which is extremely important, we have got to check our answers in our original problem. So let's check x equals to negative 5. We take negative 5 and we put it in our original equation. So negative 5 minus the square root 15 minus 2 times negative 5, and we want to see if that is equal to 0. We are checking this. So this is negative 5 minus the square root. This is 15 plus 10. 15 plus 10 is 25. So negative 5 minus the square root of 25. The square root of 25 is 5. So this is negative 5 minus 5. We want to know, is that equal to 0? Well, no, because negative 5 minus 5, that's negative 10. and negative 10 is not equal to 0, so negative 5 does not check, and we're going to have to cross that out. It does not work. So the next thing we have to check is x equals 3. Again, in your original equation, 3 minus the square root of 15 minus 2 times 3, we want to know, is that equal to 0? So doing our arithmetic, 15 minus 6, 3 minus 15 minus 6 is 9. The square root of 9 is 3, so this says 3 minus 3. Is that equal to 0? Yes, it is, and this one does check. So 3 is our solution. It is the only one that works. All right, here is an equation that involves two radicals. All right, go back to the steps that were listed on the page right in front of this. Step 1 says to isolate the radical. Well, when you've got two radicals, you have to isolate them away from each other. You can have one on one side and one on the other side of the equal sign, but you have to move one of them. So this is going to wind up square root of 2x plus 3 is equal to 1 plus the square root of x plus 1. Change that, you add it to the other side. Step 2 says we raise both sides to the index. Well, the index is 2, so we're going to square both sides. Now make sure you square these correctly. You square this side of the problem, and you square this side of the problem. Square this side, square this side. When you square the square root, you have 2x plus 3 equals. This is a binomial because of the plus sign. So we actually have to write this twice, and we are going to have to FOIL it out. So FOILing out, 1 times 1 is 1, plus, multiply 1 times that radical, that's going to give us the square root of x plus 1, plus square root of x plus 1 times 1, square root of x plus 1, plus the last term, square root of x plus 1 times the square root of x plus 1 gives us x plus 1. Now, adding like terms over here, the 1 and the 1 is 2, plus, here's an x, plus, all right, we've got these two radicals we have to add together. Since the radicals are exactly alike, what we do is add the number in front. There's understood to be a 1 in front of both of these, so 1 plus 1 is going to give me 2 square roots of x plus 1. And that is still equal to 2x plus 3. Now, can we solve this, or do we still have a radical? Well, we still have a radical, so now we have to go back and do steps 1 and 2 again. Do number 1 and number 2 all over again to isolate this radical. So, step 1 again, isolate this radical, which means we're going to subtract the 2, and we're going to subtract this x to the other side. 2x minus x gives me x plus 1 equals 2 square roots of x plus 1. This is now isolated. So now we take both sides and we can square them. X plus 1 squared is equal to 2 square roots of x plus 1 squared. This is a binomial squared, so we write it twice. X plus 1 times x plus 1, and we FOIL it out. X squared plus x plus 1, that is going to give you x squared plus 2x plus 1 equals. You square this. These are multiplied together. This is not a binomial, so you square each of these. 2 squared is 4, and square that square root, you get x plus 1. Distributive property, x squared plus 2x plus 1 is equal to 4x plus 4. This is quadratic, so put it in standard form. Subtract your 4x, and then subtract your 4. So that'll give you 0, and we have here x squared minus 2x minus 3. You may put this now in your quadratic formula or factor it. If we put this in our quadratic formula, we are going to get that x is equal to -1, or x is equal to 3. Again, these are possible solutions. We have got to check these as step 4. So when you check x equal -1, you go back to your original problem, the way it was written up here at the beginning. And everywhere we have an x, we'll put a -1. So 2 times -1 plus 3 minus the square root of -1 plus 1. I need to see if that is equal to 1. Oops, I'm sorry. Right here, -1 plus 1 is 0. So that's going to be a 0. This is going to be -2 plus 3 minus 0. Is that going to be equal to 1? -2 plus 3 is 1. The square root of 1 is 1. 1 minus 0 is 1. And this checks. So -1 is a solution. So now we need to check x is equal to 3. In your original equation, the square root of 2 times 3 plus 3 minus the square root of 3 plus 1, I need to know if that is equal to 1. 2 times 3 is 6 plus 3 minus the square root of 4. 6 plus 3 is 9. The square root of 9 minus the square root of 4. The square root of 9 is 3. The square root of 4 is 2. And 3 minus 2 does equal 1. So 3 checks also, and both of these solve our problem. Now that was an equation with 2 radicals. Notice we isolated. We squared both sides. We still had a radical, so we had to go back and do steps 1 and 2 all over again, and then check our solutions. Now the last example for this section is example 6. Solving an equation containing a radical where it is a cube root. Step 1. Radicals we have to isolate. So you have cube root of 4x squared minus 4x plus 1 equals the cube root of x. In order to get rid of a cube root, we're going to have to take both sides to the 3rd power. So to get rid of this cube root, I'm going to cube both sides. When you cube the cube root, you're going to get 4x squared minus 4x plus 1 is equal to, when you cube the cube root, you get x. Standard form. Step 3, solve this problem. We have no more radicals. So we're going to have 4x squared minus 5x plus 1 is equal to 0. Put this in your quadratic formula. And in my quadratic formula, I got x is equal to 0.25 and 1. We probably should write this as a fraction. So we got x is equal to 1/4 and 1. Now we did change the problem when we cubed it, so we should check our answers. Let's check the 1 first. That'll be the easier one to check. So you have the cube root of 4 times 1 squared minus 4 times 1 plus 1 minus the cube root of 1. I need to know, is that equal to 0? The cube root, this is 4 minus 4 plus 1 minus the cube root of 1 is equal to 0. 4 minus 4 is 0. The cube root of 1 is 1. The cube root of 1 is 1. 1 minus 1 is 0. It checks. So let's check x is equal to 1/4. We draw a line here so we won't get mixed up. In our original problem, the cube root of 4 times 1/4 squared minus 4 times 1/4 minus 1 minus the cube root of 1/4. We want to know if that is equal to 0. All right, if you need your calculator to help you with some of this, you can do this. But this is the cube root of 4 1/4 times 1/4 is 1/16. 4 times 1/4 is 1. That's all that's under the radical. Minus the cube root of 1/4. I want to know if that is equal to 0. 4 times 1/16 gives me 1/4. So this is the cube root of 1/4 minus 1 minus 1. Oops, I'm sorry. This should be plus. 1 minus 1 is going to be 0. So this is going to be the cube root of 1/4 minus the cube root of 1/4 equals 0. That is a true statement. So this checks also, and both of these check. Now you should work these problems from your book to see if you can follow along with all these steps.